Yao. What's your name,
Yao.
please?
My name is Krishna.
Okay, nice to meet you, Christina.
Okay, Yao, perfect. Yeah, and mine is like there you go, Krishna. Yeah. So nice to meet you too. So are you preparing for a specific company or like when is your interview?
Well, I actually have not yet. I mean, I've been always preparing, but I have upcoming Amazon.
Mm-hmm.
Actually, I was not so prepared when I was in Google interview, so that's why I come back to Promp.
Good idea. Okay, cool. Yeah. I have my interview on Monday with like Snapchat, like Snap. So yeah, I have it on Monday. We'll see how it goes. I don't know if I'm 100% prepared either, but hey, we can always take interviews, right? So
Yeah,
um
best of luck.
thank you and same to you. So I'm sure you will do great. So okay, are
Thanks.
you ready to get started?
Yeah, let's get started.
Okay,
Let me
cool.
see. Decrypt message.
So do you
Let me
prefer to
see.
read it or do you want me to explain it? Which one do you want to do, or in any order I can do it? Whatever way you like.
Let me read it myself first. If I have questions, come back to you.
Sounds great. Yeah.
So convert every letter to its ASCII value. Add one to the first letter,
Mm-hmm.
right? And then for every letter from the second one to the last one, add the value of the previous letter.
So like
Subtract
this.
26.
Mm-hmm.
Subtract 26 from every letter until it is in the range of lowercase a to z in ASCII table. Okay. Okay, convert the value back to the letters. Okay. So let me look at an example.
Okay.
Crime. So, okay, CRIME, and then ASCII number for C is 99, right? So,
Mm-hmm.
um, this is okay. Okay, so this step one, right? So 99 is the ASCII number for C, right? And
Yeah.
so what about 114? 114 is 114 the ASCII number for R?
Yes, that is correct. Yeah. And the
Okay,
same is the
and
case. This is for I.
okay, let me put the example on the IDE.
Mhm.
Um, so essentially the first step basically find uh, ASCII for letters.
Mm-hmm.
And mm, so step two basically is 99 plus 1, right? And then
Mm-hmm.
which is 100. And
Yeah.
then basically is 214 is equal to 114 minus 100.
Mm-hmm. Mm-hmm.
Yeah, sorry.
So you're, yeah, either way, yeah, you can get there. Mm-hmm.
So 319 is okay. Let me think. 319 is what? Uh, oh, so that's 114 plus 105, right? So is it
Uh,
114 plus one?
plus maybe 100,
Yeah, plus 100.
right? Because then you have all the sums, right? Or you can think of it as this being just 214 plus 105, right? Either way, I
Oh,
mean,
okay.
however way you want to think about it, but yeah, it's essentially
Okay,
like
so
just running it.
by that logic, 428 is 319 plus 109 then.
Mm-hmm. Yeah.
Okay, so and then the step three, we have, what do we do in step three?
So in
100, one.
yeah, sorry,
Mhm,
go
go ahead.
ahead.
That's okay. Yeah, go ahead.
So yeah, in step three, you're just making sure that the values you got on top are within the range of lowercase, like ASCII value of lowercase a through z. So that would be 97 to whatever this value is, right? So since here, let's say 214 is obviously greater than whatever this upper bound is, so they keep subtracting 26 every time until you reach this valid range, and then you got 110. Similarly is the case for 319, and then you got 111. So yeah, you're essentially doing, yeah, I don't want to give away any more things, but like yeah, that's exactly this algorithm doing. And this is actually the encryption algorithm, and then you are going to be working on the decryption. I don't even know. Okay, that's what you are going to be working on. That's like, that's what the problem is. So yeah, just to
Okay.
reiterate, like you're given a string that doesn't have much meaning because it's encrypted, and given this algorithm that you actually found, you're just gonna find the opposite of that so that you can find the original string that was encrypted.
Yeah, that makes sense. That makes sense. So basically, step three is bringing back to the lowercase ASCII numbers. Cool.
Yeah. Yeah, and everything will
Okay.
be lowercase. Nothing will be uppercase or any random characters or anything like that.
Fair enough. Fair enough. So okay, let me think. So encrypted so I will be given a encrypted message, and then okay. So I need
Mm-hmm.
to do the back translation to
Yeah,
the original message. Okay, good.
right.
Now I understand the problem.
Very
Um,
good. Yeah.
so well, to reverse engineering, to so let's say
Sorry.
that's okay. So let's see what we can do with it. So we are given
Mm-hmm.
given this guy over here, and what we can do is to first step is to translate.
Mm-hmm.
Well, translate to ASCII, and so this is
Mm-hmm.
what we are gonna get, right? So
Exactly.
um,
Yeah.
yeah, yeah, this is not hard to do. Just use Python function the ORD,
Yeah.
and then but the next challenging part would be well translate back to the original ASCII. I mean, not ASCII. Become something like a cumulative sum.
Mm-hmm. Yeah.
Yeah, cumulative sum.
That is making, that's a really good observation. Yeah.
Thanks. Um, Let me think. So I mean, the first guy will be easier. First guy is gonna be the 100, 100 just minus one. So
Mm-hmm.
this is easy. So let's look at the
Yeah.
next one. Is a 110. So how can we back translate to 214?
Mm-hmm.
Right. So let me take one step back to see how we went from 214 to 110. So
I'm going to also write down this because this will be like a good reference point for you, because you're trying to get to this number, not necessarily 214. So like, because the original thing is crime, right? So this is what you're trying to get to. So I don't know if that will be helpful to have in front of you while you work out your math.
Yeah, definitely. This is definitely gonna help. Yeah. So we successfully back into the first character now. So right now, let's
Mm-hmm.
see what we can do to go from 110 to 214 at least.
Mm-hmm.
Uh,
Yeah.
so let me think. So 110 to 14. So looks like what do so the ASCII. Let me think. So the ASCII number. So can you give me a reminder? So 97
Mhm.
is A, right? So it's B 98.
Yes, exactly. So A is
Oh,
97, B is 98, and then oops, and then C is 99, and so forth. So I
okay.
think Z will come out to be 97 plus 26, whatever that is. Is it 123 or I don't know?
Yeah,
Yeah,
something like 123. Okay, good.
yeah.
Perfect. So so the domain that we're looking at is between 97. So this is the range that we're aiming,
Mm-hmm.
right? So number has to be become this range. And right now what we have is 110. So
Yeah.
and then let me think. Um, so what I was thinking is also this. So we have 100, right?
Mm-hmm.
And then we plus something equals
Mm-hmm.
to equals to something. Let's say um, so. But how do I bring it back to from 97 to 123? Though? Let me think. Um,
I'm curious
so let
if you
me.
can.
Mhm.
Yeah, sorry, go ahead.
Yeah, I'm thinking like. So let's go back to this here, right? So
Mm-hmm.
214 minus what was it? 100
Mm-hmm.
right?
Yeah.
Is equal to. So this is this. So this is the second number I was talking about, like 214 minus 104. But how do we figure out the 104 though? That's what I was thinking.
Yeah.
Um,
So I wonder if you how to get to 214, For example, you're using two operations, right? In step 2, you're just doing addition, and in step 3, you are doing almost like modular arithmetic. So it's almost like a clock, right? Like after 26, you're gonna reset, after 26, and so forth, right? So I wonder if you have to come to 214, for example. So I think if you look into the ordering of step 2 and 3 and think about why is like the 26 are being added so many times, if you can kind of literally reverse engineer that and kind of see if for one of, like, let's say second case, if it works, or if the order even matters, like which order can you go by, and then you may be able to come to a solution.
okay, yeah, you mentioned the keyword modular.
Yeah. Well, I think of it that way in my head when I someone says keep adding 26, 26, 26 until you are in this range. But you could use modular arithmetic, but I think I use it as more to get a sense of why a step is being applied. So that way you can kind of find the opposite of that. So I wonder if that might work, right? So in my mind, when you're in step 2, you're essentially just finding the difference between these two items, or yeah, you're just like adding like the sum and going forward. So I wonder like what is like the opposite of sum, and maybe you can try using that technique, right? The summing is like opposite of subtraction, like if you want to get rid of the effect of addition, then you want to subtract, right? So I wonder if that is something you can use as your step instead of thinking, oh, how many 26 do I need to add to get to this step? You know what I mean?
Yeah, definitely. So essentially, yeah, from the step 2 back to step 1 will be minus those numbers. So I
Yeah.
was thinking, how should I go from step 3 to step 2?
Okay. So step 2 to step 3 is just applying, you're just basically adding 26, 26 until you're within the range, right? And I wonder why that step is being applied, right? So I guess as long as you can get to a point, like I guess it doesn't matter how many 26 away you are from your solution, but once you are getting to the right point, then you can always adjust however many up or down 26, right? So I wonder if that is the last step that you would want to apply. So instead of going from step 3 to 2, you can just do step 1 to 2 in your decrypted string, and then maybe apply that 26 logic to get to within the range of A through Z. So I'm thinking if you want to try that out, like in a dry run setting, and see if you can kind of think about it that way, you know?
Okay. Well, I'm not sure if I quite get it though. Let me think. So
Yeah.
you're thinking like, uh, I don't need to worry about step 3 to 2. You are saying,
Yeah.
and what I
I'm thinking from step 2 to 3 is just getting back to within the range, right? So I always think of that step as the last step I can apply even during my decryption process. But what is the other step that they apply that you can do to reverse the effect of, right?
oh, okay. Yeah, I kind of get it now.
Because the order
Um,
doesn't matter. That's, I guess that's what I'm trying to say. Like the order doesn't matter. Like if you like do addition and then you do, I guess, switch the position, like you can always come back to the same position within that range because it's like modular arithmetic, right? Like you're gonna keep coming at 12 5 times, and then you don't even have to know how many times you need to add, as long as you are moving consistently 12 steps away, and then you know the range that you need to be, you can come back from wherever. So I guess that's what I'm trying to say. I I guess that's enough hint. I don't know. I don't want to give away the answer. So let you work on
right.
it. Yeah.
Yeah. Okay. 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 Yeah. No, yeah, I kind of get it now. What
Mm-hmm.
you said. So, um, let me think. So, okay. 99, 114, 105.
And there are multiple ways to solve it too. So if you have a different approach, feel free. I mean, sometimes I learn like new techniques too. So
Okay. Okay. That's good to hear. Yeah, I was thinking. So this is what I was thinking, right? So,
mm-hmm.
uh, I have 99, which is 100 minus one, and
Mm-hmm.
then I have 114,
Mm-hmm.
which is which is some number that is from let me think. It is from the 100
Mm-hmm.
plus something. Well, okay. So yeah, so we have the code right here. So 110,
Mm-hmm.
the
Okay.
110 equal Yeah, 110 is equal to what we had before was 100 plus 10, but the 10 is um, but let's try something. I'm not
Yeah,
sure if I'm going the right direction. So if I take the difference between each the two ASCII number, so
yeah.
the first one I'm gonna 99, I'm gonna get 10, 1, 5,
Mm-hmm.
and -3.
Yeah. Let me pull up the calculator so we can do the 26 thing, right? So yeah, I actually think that I agree with that. So yeah, let's start here, -3, right? So what do you think you might want to do for it to come within some range, for example, within the valid
What do
range
you
for
mean?
So I think you are on the right track, right? So you found the differences, right? Between
Yeah,
so
okay,
this
yeah.
is essentially going from left to right, cumulative sum. You could do the same thing and try to like keep subtracting or whatnot, but essentially you're finding the difference, right? So I
Mm-hmm.
guess that's the point. Even though this isn't gonna give you the exact number, let's say like 529, it is exactly certain number of 26 steps away from the solution, right? So I wonder, from -3, if you want to reach 101, what operation would you want to do? And that would help you get to the answer, for example, right? So
Do
is
you have a
negative,
calculator?
yeah, yeah,
Yeah,
that's exactly
so
what I
uh,
no problem.
so
Okay.
20, 26 minus 3, what do I get? 23 plus 26, 26, 26. Oh, okay, I kind of get it now. Okay, okay, I
Yeah.
understand. So
So you got
essentially,
101, right?
yeah, I can add 26 multiple times and get it back to the range.
Mhm. As many times as you want, right? So I guess that's what I'm saying. If you're at point A on your like line, for example, and then let's say everything is like 26 steps away to point B and then 26 points away to point C, I think it doesn't matter whichever point you land. As long as you know it's exactly 26 steps away, you can use that adding 26 or subtracting 26 to get to the right solution. And I think like that's
Right.
like the crux of this whole problem. And you solved it.
I'm not sure I will solve it.
Almost there, almost there. I think you got it. So we can do a dry
I'm
run
running
and
out.
then you get it.
Yeah, I'm running out of time, but let's try what can I do with the next few minutes. So
Yeah.
so 101 is equal to -3 plus 26 times something. I don't really
Yeah.
care.
Mm-hmm.
And then 109 is the same idea. 5 plus
Mm-hmm. Mm-hmm.
26 times something.
Yep.
Uh, so for so basically, I need to bring back to the range that we talked about before, which was 97 and 123.
Yes, exactly.
And then luckily, we have something which is in that range, so we don't have to do nothing about that.
Yes.
Um,
But if it
okay,
did
I
not
think
used to be, then you still want to do that for even the first number, right? Let's say
yeah,
it became like, yeah.
I'm thinking about like a while loop. If
Yeah.
yeah, like a do until
Mm-hmm.
we are there.
That makes
Okay,
total
great then.
sense. Yeah, that makes total
Perfect.
sense.
Let's go. Am I good to code?
Yeah, I think that's good. I was gonna ask you, like, you can think about the edge cases like when you actually code or like right now, whatever it is. But I think your logic is in the place, so you are good to go.
Yeah. So the edge case will be like something like empty string.
Mm-hmm.
Uh,
Yeah.
yeah. So that's empty string. We just return empty. Let's just
Yeah.
worry about that later. I'm running out of time
Yeah.
because
Yeah. Yeah.
let's
Yeah. That
see what I
sounds
can do
good.
with it. Yeah. I think for time complexity, it's gonna be big of n.
Mm-hmm.
Also, there's a nested for loop, but that one is gonna be has a constant time is because yeah, I think it's big O n. So
Yeah.
let's see. Okay, so I'm given a word, right? So let me see. The word is, let's say, equal to this guy over here. Now I need to come. First step is to convert it to the Ascii code. Okay.
Mhm.
So for char character in the word ASCII list equal to this. Uh, I'm just calling it a list. It's just save time.
Okay. Yeah.
ORD.
Mhm.
Okay, now at this point, what we have is it's gonna be equal to something like this. So okay, right?
Mhm.
I basically nothing going on, just not much going on, just converting back to the ASCII code.
Yeah.
Right.
Totally agree. Yeah.
Let me think. So and then for uh, yeah, the first one is gonna be easy. I'm gonna do the first one first. So
Mhm.
the first one, uh, so let me think. So if the first one in the range of in the let me think. Oh, okay. So it's gonna be how can I compare the number in the range though? Let's
You
say
can just use the same functionality, but then instead of like C, you can just call this like A, for example, you know? And then for the other side, you can just do like OR and then Z. So that's your valid range. That way you don't even have to like type up the actual numbers.
yeah, but okay. But I have to I need to have a set or list that have all the numbers between 97, 98, 99 to 123, right?
Oh, why would you want to have that?
But if I don't have that, how can I know that if that number is in the eligible set a range or not?
Oh, just by an if statement, right? You can just ask like if 100 is in the range of, you know,
Like
or
this?
uh,
No, I don't.
oh, I think I was just gonna say like if it is like greater than, for example,
Oh right, I
order
yeah
of A, and less than order of Z, like kind of like that. But I don't want to
yeah yeah
overwrite. So yeah.
yeah. Sorry, I was getting nervous. That's why my brain was not.
That's
Uh,
fine. I would say like you're doing great. Like don't this is the one question like every single person I have like given to, and I have given to like 5 people already. Everyone kind of like struggles like to come up with the solution. So you're doing pretty good. Like keep going.
you helped
Yeah.
a lot. You helped a
No,
lot.
it's fine. I think it's kind of like stressful, like because you meet someone like brand new. I totally get it. Like I used to make a lot of like mistakes, so we just learn by practicing. That's all.
Let's do like a 5 4 minute, 5 more minutes. If I cannot get it done,
Yeah.
I'm gonna cut it and then swap it back to you.
I
Is
actually
that
have
does it work?
time. Yeah, I actually have time. So if you want to go 10 minutes, that's fine too. Like if you have time, then I don't mind. But if you have to go, then yeah, 5 minutes is fine. I'm like, relax, it's fine. Take your time.
Yeah,
I want you to be able to like take away something from the problem rather than feeling
yeah,
stressed. So it's just the opportunity to practice. Yeah, just take your time.
yeah.
That's like the whole
Thanks,
point of it. Yeah,
thanks.
no problem
Okay,
at all.
so um, while not in that range, what we do is yeah, okay, what we do was to add 26. Okay. Uh, we'll have a temp number, so I'm gonna do temp minus 1. So while the temp is
Okay.
okay, yeah. When I get out from the while loop, while we're getting in that range already, so and then the first thing I'm gonna do is convert it back to a character.
Okay. Perfect. So
But
that would
what was the
be, I think it's just this to convert back.
char? Okay,
Yeah,
okay, good. Thanks.
no
So
problem.
okay, let's have the result is an empty string. Okay, dot print. Oh, I don't. Maybe but okay, just concatenate.
Okay.
Concatenate a char of temp minus 1. Okay, now I get the first one nailed down at least.
Okay.
So
Yeah.
I'm gonna worry. I'm gonna worry about the rest.
Okay.
So yeah, what we talked about before was taking the difference. Okay. I'm gonna have a no probably yeah. I'm gonna have another external array. So for and in a list. Let's see. So what we gonna get is the div dot append. Oh, I look at the number in the pairs. Okay, good. That's okay for okay index in the range of the length of that, and let me think. First one is 0. The last one is let me think. Probably minus 1.
Okay.
Yeah.
Are you
So
sure? Okay, okay. I see what you're saying. You're going from left to right. Okay, okay.
yeah, exactly. So gonna be I plus 1. So I'm taking the difference.
Yeah, yeah, yeah. And then so that any point you are in within the valid range. Okay.
Yeah, exactly. So after I get out from this for loop, what I'm getting will be let me think. So it's gonna be um, uh, 10, 1, 5, and negative 3.
Okay. Yeah.
Okay, so okay now for for x in div if x is okay, I'm gonna copy this guy over here. I think it's gonna be useful. So while x is not in that range, what I'm gonna do is to have let me think. Yeah, I think this is gonna be okay. So x equals x plus 26. And then after I get out from here, I will have a valid from A to C lowercase character, and
Yeah.
let's convert it back to okay. So okay okay. So the answer that we had before was so dot append the character of x
Mm-hmm.
I think this is about it.
Wait,
What do you
wait, wait.
think?
But after this looks like the steps you followed, but like there's something missing in the function. So you actually do have this, but then what are you
Yeah,
returning?
yeah,
Yeah.
exactly. I need to return that at the end.
Okay, perfect. Yeah. So I think this exactly follows the logic of the algorithm. Now I was
Yeah.
wondering if you want to go ahead and run tests, or you wanna
Yeah, I'm
you
fine with that. Actually, probably there's some bug here and there, but I don't want to waste time to debug.
okay.
Because in
Yeah,
a
yeah,
real
no
in
problem.
a real interview, probably
Yeah.
if I had at the time,
Mm-hmm.
now I don't. I would probably do a dry run after this. I mean, a
Yeah,
verbally dry run, but
yeah,
I mean, in a formal interview, if I had a chance,
yeah,
probably I would do a dry run. But today, probably
yeah.
not. So,
Okay, no
and
problem. Yeah.
thank you so much for your help, and you
Yeah.
really helped me a lot. And
Yeah,
now
no
let's see what's
problem at
what.
all. I was actually gonna tell you though, one thing I would say, like feedback wise, that will be really helpful is for things like this, you can just use list comprehension, so that could be helpful. Like, so if you are literally just doing word of C for C in Word, so this is literally gonna give you um it literally is just going to give you the same thing. So if you're going to use like Python as a language, this will be helpful because then you're going to send this impression to the interviewer that you know the syntax, which is one of the things. And the other thing I'll say, like string concatenation like this, um, because strings are immutable, right? It might be that you're literally using up a lot more space, so it's much easier to use like this join syntax, and then you just provide like a list, for example, or whatever, like the list name, for example. So I highly encourage you look through this, because this in itself, like if you concat the list, I mean the string along the way, it will be a sign to the interviewer that you didn't worry about the space complexity. So every time you add, you're creating a new string, and then you're taking up that space, and then you're taking up another space versus another. But when you use join and you provide just a list of characters, it will go through just once and it's done. So I would not do this for sure. And then I think list comprehension was just like my one small thing that would be helpful. But yeah, you did a great job though. Thanks. Like you took the hints, you turned around. Great job. So
Thank
yeah, I really appreciate it also, like you staying on top and not giving up. So that was great. So yeah, let me see for this one. What is the question? So I'm going to read through this. I'm going to explain as I read. And and after that, like if I miss something or if I have any clarifying questions, I'm going to ask. Okay. Okay, so this question is sales path. The car manufacturer Honda holds their distribution system in the form of a tree, not necessarily binary. So it's like an honorary tree. The root is the company itself, and every node in the tree presents a car distributor that receives the car from parent node and ships them to the children node. So it comes from 0 and it goes to 5 and 4. So it's like directed edges. The leaf nodes are car dealerships that sell cars directly to consumers. Okay, so these sell cars directly to consumers. In addition, every node holds an integer that is the cost of shipping a car to it. So this costs 5, this costs, ooh, what is this means? To ship to this node costs 4. To ship to this node, it costs, and that's why this is 0. So this is the example, a path from Honda factory to car dealership, which is the path from the root to leaf in the tree, is called a sales path. The cost of a sales path is the sum of the cost for every node in the path. So from here to here, the total would be 9, right? The
Yeah,
cost of
exactly.
Okay, perfect. So in the example about, in the tree about, one sales path is 0 to 3 to 0 to 10, and that would be 13. Honda wishes to find the minimal sales path cost in its distribution tree. Given a node, root node, write a function, get cheapest cost that calculates the minimal sales path cost in the tree. Implement your function in the most efficient manner and analyze its space and time complexities. For example, given the root node in the diagram, it will be 7. So 7 because it is going to go through 0, 6, and 1 maybe. And also you can do 0, 3, 2, 1, 1. Yeah, okay, so 5, 6, 7. The time limit, it times out at 5,000 milliseconds, and the cost can be at most 100,000, and the output has to be an integer. Okay. So yeah, and then you're given a node class that has a cost, has children, and then okay, you can refer back to the parent as well. That's great. um so yeah, okay. I guess like some edge cases could be that you only have the root nodes and you don't like, that's basically all you have, or you can just, you're given none as your root. So that's like a couple of things I could think on top of my head, but I guess we can kind of think about it as we go. I wonder the cost is positive. Okay, great. Because I was curious, if it is negative, then it's an issue, right? And other thing is, it seems like it's a tree data structure and not like there is no cycle. So that's great too. And it's connected. Okay. So I would say like my approach would be to use DFS in a recursive manner. So if I were to start at like the root node, I would call the recursive function on all subtrees, and I can see, okay, what is the path cost in this tree, and what is the cost in this tree, and then find the minimum of all of them. So by doing that, we'll keep going down, and if we reach the our base case would be when you reach the leaf nodes, or sorry, none. Because when you are at the leaf node, you're gonna have no children, so your children's length will be 0, and then like that is the cost, and then you just keep adding the cost upwards, and then once you reach here, you're gonna be able to find the minimum. I would say if we take the DFS approach, it will be linear cost, because you're going to be traversing all the nodes and the edges. So O of V plus E, where V is the number of vertices and E is like the number of edges. Um, yeah, I think like you cannot do better than linear, because you're literally how to traverse all the nodes and edges to be able to know it, right? And I think the space complexity would be, because you're doing recursion, in the worst case, you're gonna have like the height of the tree in your active recursion stack. So, or height or depth, whatever you call it. So the longest path that is from the root to the leaf node would be the space complexity. So I'm curious, like, what are your thoughts on my approach to see, what do you think about it?
Yeah, very well thought. And I mean, you voluntarily answer the time and space complexity. That's awesome, and also you correctly answer those questions. And also you mentioned that you want to do a recursive approach, which I like as well.
Mm-hmm.
And also you analyze the possibility to further optimize it, which in this case is not possible because you basically have to search all the possible branches.
Yeah.
So yeah, I think you are good to code, and let's go ahead.
Okay, great. Thank you so much for that. So let's see if this is, I think I would want to create like another recursive function within it. Um, and I'll just say if I pass on node. And the reason why is because at every recursive call, I want to pass like a cost or something back. Actually, I may just not, because I can just return the cost here too, right? So actually, yeah. maybe we don't need a recursion. I guess if we need it, we'll do it. So, but for now, I think I should just be able to just find min. I think, yeah. So I guess my base case would be if the root node is none, right? That means you reached, or not none, root node dot children, the length of that is 0, because that's how we are actually tracking it. If that's the case, then we just return the cost, right? Return the cost of it, right? So then, oh no, you don't have a cost, so you just return 0. And then it will come back. The next call will be on node 4. So in any other cases, you're going to call for child
Wait a minute. Wait a
in,
minute. So I think you were on the right track where if
mm-hmm.
if the node has no children and but it does
Oh
have
yeah, I was
calls
on
on
the
it.
right. Yeah, that's true. Then
Right.
I
Yeah.
actually do want to call the root node
Right.
dot yeah, because this is not like where you have just, you never gonna have none, so you do return the cost at that point. You are right, sorry.
Yes.
So you are
Perfect. No
returning,
problem.
and yeah, thanks for correcting, I appreciate it. Yeah, okay, so yeah, you're right. And in any other cases, you're going to find, okay, so let's see if I can create like something called min cost, which is initially set to 0. And what you do is you see for all the child, you can get the minimum cost of that node, going through that node, and then you do min cost of all of those, right? Uh, and this. I think by doing that, you're calling recursively on each of the child and you're finding the minimum cost. And I think you're also adding something too. So you return 4. I think plus is missing somewhere. Kind of bad with recursion. So you have 4. Yeah, I think you do want to add the, oh yeah, and then you ultimately return the min cost with the cost of that node. Uh, Sorry, this is
Perfect.
not sure why.
Perfect. Yeah.
So I think this might work, but I think I generally make a lot of bugs in my code, so I just wanna like just think through it one more time. Sorry, so I can like verbalize and think about it, right?
Mm-hmm.
So let's say I started at this node 0, right? So I'm just gonna create like a stack here so I can see. So 0 is gonna call, and 0 has children, right? So it's gonna call 5, is gonna call 3, it's gonna call 6, and then I think I'm gonna go and finish only one branch so we don't take so much time. Sorry about that. But then
No
5
worries.
is gonna,
You're done well.
yeah, okay, perfect, thanks. So 5 is gonna call 4, and as soon as we hit 4, we realize 5 doesn't have any children, so it's gonna come back and return the cost, and then it's gonna say, okay, here I got 4 here when at 5. And since 5 doesn't have any other children, the minimum cost is going to be just 4. So it's gonna go back and return to 0 here 9. So, oh, sorry, and every single one of them will give some kind of values here. So we're just not gonna for
Perfect.
now do it, but it will work. And then at 0 node, you are gonna get all of it, and then you literally just gonna add 0 to it and you return it, right? So I think unless I did some weird syntactical error, it should work. So let's do a
But
search.
the on-
Oh,
the only
yeah.
problem the only
Mm-hmm.
problem is you initialize the cost is 0.
Mm-hmm.
Think about it. Why this may not be the best way.
Oh, I can do like -1 because the range
Mm,
of the nodes are right?
Hang on, think about it.
Oh,
Think
no, no,
about
no,
it
minimum.
because
Oh, yeah, yeah, yeah. I need to do this. Okay, I think that's
perfect,
true. If you're
perfect,
minimizing, you want
perfect.
to set it to maximum. Yeah, 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 yeah. Sorry. I just didn't think through it. I was like, I know there is something. Because otherwise, if you have five, you will always get zero and it wouldn't be smart.
Exactly, exactly.
So,
I know you're getting it.
okay,
Okay.
perfect.
Um.
Um, yeah.
Before I let you go, and well, because you're going for Snapchat, so I have to increase the difficulty for this problem for you.
Yeah, yeah.
And
I'm not that good though. But let's see. Yeah, let's
you
see.
are doing really well. You are doing really well, and this is
Thank you.
yeah. And so yeah, well, you basically at this point you get 4 mark. But if you want to do get bonus, I will
Mhm.
ask you a follow up question that um just not solve it to and instead of using a recursion, think about how
Mhm.
you solve it to use a iterative approach.
Iterating approach. So I feel that for an iterative approach, and this is just me knowing that whenever you can do recursion, you can do the same thing with a stack data structure. And actually,
Exactly.
they also gave us parent, which is really convenient. But if they didn't, even if they didn't give this, I do think that by putting everything in stack, you're essentially doing the same thing as recursion, right? So maybe I have not thought about it. But let me see. So you're going and putting this into a stack. I guess I can like go through like stack structure and see what I can do, right? And then I would put
Okay.
all the children of but then I think we still need to know levels, right? Don't we need to know levels? This is a good question. So you might want to put, for now, let's just track levels manually and see how it even works approach wise, right?
Right.
Then you have this, then this person is gonna put all of its children. Actually, no, when you are here, so in recursion, we are doing this, four, or yeah. Then you come back, and for the next child comes, and that next child puts its children, and then so you're just doing like BFS. Have never remembered like how we did DFS. Oh, okay. So one goes down, and then one, yeah. Actually, um, let me think through this again. And we pop only when we reach a child. So, hmm, maybe can we do it like in a way where we set a current node, for example, as root, and then we can do like a weird like while loop, and then we can kind of break. So if the current node exists, so it is not none, right? So if it is existing, I wonder if current becomes current dot left, because then you're going down, down, down. Or no, you can't even do left. You have the children of the current node, right?
Yeah, you're getting
If
there.
the current
Perfect.
node is and current node dot children, right? Then you
Hmm.
wanna go ahead and make the current node the children one by one. No, this won't work. So what is, I guess I'm looking for some hint. I just know like in general that you can do the same thing with stack. I think you can also do it with like parent pointer, because you can like just so keep going down, and then as soon as you hit where there are no children, then you can go back using the parent pointer and then keep summing it, right? I guess I don't even need to use stack. So start here.
Yeah.
But how do we find min? How do we find
Yeah.
min?
A little hint for you is well,
Mm-hmm.
you may or may not need to use the parent. I didn't use it. If you want to go
Mm-hmm.
back, maybe you can use it. I didn't.
Mm-hmm.
And
Mm-hmm.
same with many graph problem. You can either
Mm-hmm.
use the DFS or the BFS. Well, BF, yeah. So basically, you use the BFS. You go like once.
One level.
levels,
Mm-hmm.
and then
Mm-hmm.
yeah, and then DFS you go to the bottom. I mean, for this case, you have to traverse all the path anyway, right? So yeah, because
Mm-hmm.
there's no shortcut that you cannot skip any path. So
Yeah.
the BFS and DFS makes no difference is in this case. And
Mm-hmm.
my hint for you, I think you get all of that. I'm just
Mm-hmm.
iterating for you to have a maybe reminder. My hint
Mm-hmm.
for you is think about what you have been doing, right? So basically, you keep track of. Uh, you might need some sort of tuple or some sort of tuple, right?
Mm-hmm.
And keep track of the the current
Node.
node and
Mm-hmm.
also the cost at that point.
Oh yeah, that is true. So
And
then
this
when
is
you
what
pop
you
it off, yeah.
yeah, and then you can compare, right? And then you basically
Mm-hmm.
the cost at that point will be every cost like below it, sum it to that point, and then you can compare when you have multiple children.
Mm.
This is what you're doing in here, right?
Yeah, exactly. So yeah, I think though, so I guess so you're tracking the current node and cost, but I guess my question would be like, how would you put it or store it in what order, right? Like I get it, but I guess that's where I'm struggling, right? So you started out with root, so that's 0, 0, right? Then if you're doing BFS, then you're gonna go to 5, or I guess let's say this is the second level. I don't even know how to do it, but let's just say like we track it like this, so we know what is a parent, what are the kids, because you may not know that. But let's say then you have I'm just gonna call it 5 because I don't have any other way to describe it, right? It's this is going to be like a node, so let's just call it node, and then 5, and then you have um oh,
Yeah,
so this is a
yeah. I
cumulative
think
point up to that point.
exactly. So
Okay.
basically, you go from the top to the bottom. At that point,
Mm,
how many calls you have collected at that point?
okay. So when you
Exactly.
reach
I think you.
5, you're already
Mhm.
doing 0 plus 5, 0 plus 3, 0 plus that. So
Exactly.
it's almost like, I mean, it's not like really Dijkstra relaxation, but you're just like taking that and you're pushing it down. So when you reach here, you already know the total cost. And
Yeah,
then
exactly.
once
Exactly.
you reach it, then you just from the kids, like you can do that. So okay, so
Yeah,
it is
exactly.
the
Exactly.
DFS source, because 0 and then 5 and then 9, then 0, 3, 2, 1, 1, and then all of that. And then ultimately when you can no longer go, maybe you might just append that within like a resulting array or something, or not even append, just keep seeing if it is lower, then get rid of it, right? Oh
Yeah,
yeah.
exactly.
So yeah,
Yeah, exactly.
that's essentially this is doing too. Yeah, and I don't think we need parent node for it. Nice. Okay, so let me see maybe if I can do it like that. I have never done like n array tree kind of thing. So let's say current node is root, right? And then while current node has children, and I guess I can just write like this. When I say like this, that means that it has children, right? I don't need to say like len equals 0, but let's just say verbose and we say it. While that is the case, then current node equals, okay, so for child in the current node dot children, then you would want to go ahead and sum it, right? I guess if we are allowed to change the cost of a node, wouldn't that be okay? I mean, can I just not change the cost like thing here already? I mean, it will change the cost of the, but I guess we don't want to modify that, right? So maybe
Yeah,
we
you can
do
have
create like a,
you can have a external storage to yeah. You can
so let's just
uh
say what do we call this? Costs, for example, right? And it's a dictionary. So for each of the child, for let's say they have children, for each of the child, costs dot append each of the child, and I guess child dot cost plus. Oh, it's time for us to go. So I can do this on my own, but I think I'm gonna probably try and finish it and see, like, you know. But
Yeah,
yeah.
yeah. Well, I went over time, so feel free to continue if you have the time. If you
Oh,
want,
really?
that's up. Yeah.
Um.
I went over time, right?
Okay. Yeah. I don't yeah, either way is fine. Give me like maybe 5 minutes and see what I do, because then you already have the approach, so you can kind of correct me. But if you have to go, like, feel
Yeah.
free, like, no problem. Okay.
No,
So
yeah.
for
I'm
each
okay with that.
children,
Yeah.
okay, cool.
Don't stress out.
So when I do this, but then I guess my question is, like, how do I like set current node to each child? Like, that's the part I'm kind of not sure. But let's say here I came here and I created a tuple of 5, and then I'm saying, okay, current node's cost is 0 plus 5, so this is 5, this is this, and I appended it here, right?
Yeah.
But
So
then,
probably my interpretation, this is a list, right?
okay.
You basically, is it a list, or because you doing append, right?
Oh, yeah, that's true. I think what I meant to do is,
Yeah. What do you want to do?
I meant to do, I think I wanted to do like this, but I didn't do, I think I ended up like not doing it.
Okay.
That's
Okay.
more
Let me
like
see.
what I want to do. So you can
Okay. Let me
constantly
see.
look up the thing, right?
Yeah. Okay. Let me see. So your key is the child at that point. Okay. And then the value being the cumulative cost at that point, right?
Yeah,
Uh,
cumulative cost at
uh,
that point. Yeah. But I guess I'm not sure with this BFS iterative approach how I go lower down. Like, so when I have to set the
yeah,
current node,
yeah.
then I cannot just say current node equals this, like, because now I have so many children, even like in a binary tree. Um, so maybe we might wanna. I don't know how the iterative approach goes.
Yeah. Let me
So
help you
for
out a
each,
little bit more. Yeah.
yeah.
Let me help you out. Yeah. So I actually use a BFS, but the same idea.
Okay.
If you use the DFS,
Yeah.
basically the difference between the BFS and DFS, just one is the queue, another one is the stack, right? So
Oh,
and
okay.
yeah, yeah. So let me help you out to get you. I mean, you have the right thinking already, but there may be
Mm-hmm.
some
Yeah.
modification. So let's say you have a
Yeah.
queue, right?
Mm-hmm.
And
Yeah.
then you wrap it off on the list, right? So basically, the
Mm-hmm.
information contained is the
Yeah.
node. That's
Yeah.
exactly what you have, right? Also,
Oh, okay. Yeah,
the
yeah,
cost
yeah.
at that point, right? And then
Mm-hmm.
what you do. So for a standard BFS template, so while
Yeah.
there's something on the
Well,
queue,
there is a,
and
yeah.
then you keep appending to the queue, right, until
Mm-hmm.
completely done. Yeah,
Yes, exactly. Yeah.
yeah.
Oh, okay, I see.
Yeah.
I see. I think now I finally get it. So so first you want to pop the node off, right? So,
Perfect. Yeah. You get it now.
actually, can I use decu here? So I can use
Yeah.
like the familiar like syntax that I know already.
Yeah.
So,
You can use
but
that.
also
Yeah.
because I can do either way, like, so I'll call this like a tuple. Okay. So we're gonna do node dash cost, and then we can do pop left, because it's gonna, you append from right and you pop left, and then for child in node dot children. So this is fine because this is just a list, so if there is none, this loop won't execute, right? um q dot append child, so we don't have cycles, so we don't have to worry about visited. And then while we do, we don't just append, we do child plus cost plus regular cost, right? Like this costing.
Perfect. Yeah, perfect.
So
Yeah,
then, and then ultimately, every time you pop left, oh no, how do we know we reached the children now, right? Uh,
exactly.
so that's when we have to compare. So I guess this is where you
Well,
have to check somewhere that that it has children.
yeah, yeah, exactly. You just put a simple
So
if statement to check.
yeah, if node, if the length, I think I can just do if node dot children,
Yeah,
and
yeah,
if it
exactly,
doesn't, if not, then you already reached a point where you have
exactly.
so then you can have min cost equals float infinity, and then you can just do min cost equals the minimum of this, and
Yeah, you're
I guess
killing
then you
this.
can just
Good,
do
good,
the
good.
cost, right? And I think
Perfect.
this
Yeah, yeah.
might work, and then you return the main cost. Wow, that was good. I literally had no confidence that I would figure this out at all. So thanks for your help. Actually, since you helped me, I also have solution of the other one if you want me to paste it in your one too. Where is
Yeah,
it?
and
Actually.
before that, yeah, before that,
Mm-hmm.
there is more things. So if there's no children, and
Mm-hmm.
actually this one will be in the elf, right? Sorry,
Yeah.
else.
So we don't want to,
Oops.
yeah, exactly. So we don't want to, you're right, because we don't want it going into this afterwards anyways. Yeah. So we don't make it do unnecessary work, right? Yeah,
Yeah,
that's true.
perfect. Yeah, I think yeah, this is gonna work.
Thank you for showing that. Appreciate it. Okay, I had it. Where did I paste it? Actually, you know what? I think I have a way to maybe duplicate and then
It's
put.
okay. I
Oh, it doesn't allow me to access past like things just like that. So, what I'll
it's
do
okay.
is after call, I'll just paste the solution at the bottom, so you have like another solution if you wanna take a look or something, from one cumulative like just differences or something like that. So yeah, but thank you for your time. I appreciate it, and good luck with your interview.
Yeah, good luck with Snapchat, and yeah, hopefully you are in where you are in US or in Canada. I'm actually located in Canada.
Oh, really? No, I'm in the US. Yeah, I'm in Texas. So I just like attended GHC, and I really like the people there. So they have like their sessions on OYE, like their own platform, and I just attended it, and then I don't know, like they like my background, I like the team, and I told them that I have a deadline coming up for another offer, so they expedited. Like I didn't even have to do assessment. Like I'm literally just gonna get an interview with an engineer. So I'm like working hard for it, but I'm not fully prepared, but I'm still just gonna go and just do it. Like, because sometimes you might get the problems that you already feel comfortable with, or like it just clicks, or you might have a good interviewer. I don't know. So that's what I'm hoping.
You you are more experienced engineer, or you are just graduate from university.
I'm still in school, so I'm just looking for only like an internship. So yeah, I only have done one internship so far with Qualtrics, the survey company. That's what people say, but they are not just survey company. They are doing so much more now. But so yeah, I had my internship with them this summer, and then they gave me a return offer, and it's nice. Like i just I just think like I wanted to see what else is out there, and
Right,
Qualtrics
yeah, 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 yeah.
pays well, but like not. I feel like other companies can pay more, so I'm like thinking that I'm gonna accept Qualtrics and do one more internship, and then if something changes, then I can like tell them. Like that's like my plan. Yeah.
Yeah, yeah, exactly. So in Texas, are you in UT Austin?
And so I am actually going to UPenn, but my program is remote.
Oh, okay.
Yeah. So mine is not like a regular master's program. Like it's designed for people with non-CS background. So I actually am a CPA, but I did it for like good 6 years. But then while I was in school, I started this master's program like one class at a time. And then I finally quit my job because I felt like I could do software engineering, But
Right. Yeah.
yeah, so my program is called MCIT Online Program. So basically, a lot of my program is like catching up on bachelor stuff, and then our last few semesters, like they make us do like the actual grad electives of four of them, and they make it really rigorous. So I'm like so behind
You,
on my school. I'm trying to do like interview practice in the meanwhile. Yeah.
you have a very similar background as I am. Actually, I'm from a math background.
Oh,
I'm
really?
actuary,
Cool. Yeah.
and I'm actually also doing an online CS master and from UT Austin.
Oh,
Uh,
cool. Nice.
yeah, yeah. So when you mentioned that, I really get it. What your challenge and where you see, and so
Yeah,
uh,
you're doing
it's not
so well,
easy.
huh? It's not easy. It's
I've
so
been
hard.
I've been doing this for the Promp because I got a interview with Google like a month and a half ago. I didn't get it because I didn't do so well. So the
Hmm.
question I got was I'm not sure if you get it. You will get the same question on Monday. But if you
Yeah,
get it, but if you have time to prepare, I would suggest to do a let me type it over here. But
yeah,
that's from Google though.
yeah.
Is to code
Hmm.
a Python
Hmm.
iterator.
Oh, really? Like they told you to do an iterator?
An object, yeah, do an object.
Oh,
So it's
wow.
object design, yeah. So I didn't get that,
Hmm.
but yeah, I'm not sure if you get the same thing from, probably not
You
same
just
thing
have
from
to,
Snapchat.
yeah. So you have to be like really space efficient. And then you also
Yeah,
have like this next method, and you have to throw an
through an
exception,
error.
right?
Yeah,
Or an
exactly.
exception
Yeah,
when you no longer have uh, elements left. So I wonder
exactly.
if you have iterator, it's just like literally just sending things out. Like you cannot change iterator once it becomes an iterator, right? I don't really remember enough, but I knew there was like an iterator interface in Java. So I wonder how Python's iterator is like, and what kind of method are there? Did they
Yeah,
tell
I
you what
was told.
method? Yeah.
What do you mean? What method? Well, I was asked to code like the class,
So did
the
they have
object.
like, but I mean, yeah, but within the class, like, did they tell you like, for example, next is one of the method, right? Like things like
Yeah,
that, like,
yeah,
or what other methods
yeah.
did you have to code besides next?
Yeah, I don't remember exactly. But the gist is to code up the iterator as a, well, they have some modification of they didn't ask me exactly code up as iterator, but they code up
Mm-hmm.
like a modification of the object. I don't remember exactly what it was. So
Yeah.
now, yeah, now I know that well, data structure algorithm is important. Another one is like object design. Object design
Yeah.
is really important. I talked to a
Yeah.
few problem guys, and
Mhm.
some of them told me that they went for interview with Amazon. They code up like library bookstore borrowing system.
Really?
And yeah,
Wow.
so also another guy told me he was with Google. He was doing like a file search system on site. Yes.
Wow. That sounds
So
so intense. Oh my gosh. So are
yeah,
you
so
applying for full-time role or like internship position?
from what I heard from the guys, they are from full time.
Oh yeah.
Yeah,
So one thing I know for fact that Fang, like the best way to get into Fang is do an internship and get a return offer because your
yeah,
interviews
yeah. That's
are
easy.
much easier. That's what I'm trying with Snap because I don't think I'm ready for Fang. I mean, I might still do it just cause like I have, so within my program, we already have so many people who work at Fang companies. So they are willing to refer us, but I'm not ready. But I'm like, well, I might as well take a chance while I can. But yeah, so most of them are like, seems like they want you to like basically implement like a class and like watch you code and things like that. Like, wow. Okay,
Yeah,
I have to.
yeah, that's one type. That's one type I heard from people
Yeah.
when you grind through leak code, right? So most of
Hmm.
them is data structure algorithm, but
Hmm.
maybe
Yeah.
smaller chunk of it is the object design. But don't
Yeah.
ignore those. Yeah, they those can be important.
That's really good because maybe if Snap does that. So have you heard the concept of CRCs? Like,
I do not know. I do not know
so if
CRC.
anyone ever tells you to design a class, like you wanna, so first they give you some kind of something, right? That this class does this, this is what this is supposed to do, or you speak it. So then CRC is like you kind of like decide nouns. So nouns are like either variables or something else, and then you have actions, right? So actions are like your methods, and then in order to, so that would like create like a CRC for you. I guess like if you Google CRC, you'll get a better explanation than what I'm kind of telling you. For
So
object oriented design.
this is an object. CRC is an object.
It's like how you design before you design a class. You want to do like a CRC design. So I think like it's like a simple way is just put CRC object oriented design, like this thing in the. So in my school, like when we took the first class, they told us that before you even start writing a code or you start designing anything, you create a CRC. So you know how in our solution first we write down our approach that I'm gonna do DFS, this is what I'm gonna do. So the same thing, there is something called CRC. And I think if I can share like an image. Okay,
Yeah,
yeah,
I'm
this
seeing
is
that right
like,
now.
okay,
Yeah,
yeah.
class
So this one, for
responsibility
example,
collaboration.
yeah, exactly. So this one kind of tells you that you have the name of the class, then you have the, like on the left side you can have methods, on the right side you have like variables or instance variables, whatever you want to call, and then you just list this out first before even you code, because by doing this you already make that interviewer agree with you on the things that you are going to design, right? But then once you get into methods, the key is to have a lot of helper methods and never write it. So I found this guy works for like some Google, like but he does a lot of C++, and he was anonymous, so he could like actually tell how he did. So he said sometimes when you don't have time, when you have open-ended question, you can create helper methods and not even implement it, and it's fine. Yeah.
Really?
Yeah. Yeah. So that's the reason why he created like a fake account. He didn't show his face, and he's like, I want to make sure that I can speak freely about my experiences. He works at Google and he worked at Facebook before it too. And like, I guess he was like a smart guy because like, he's like, I only work like 20 hours, even though I'm supposed to work 40 hours, but I just get my job done and that's it. So yeah. So some people are like this, but maybe, so he was saying that this is like methods, like when you type, just write only helper and move on, and then you can implement it later. But at the end of the day, if the time finishes, they may just say, okay, don't worry about helper method, I know how you can implement it, and they might just like be like, okay, makes sense. I mean, we want to ideally want to do helper, but yeah. So I think next time this comes, like have the interviewer agree on CRC first. That way we don't have to think about like too much. And then, but I think I'm gonna brush up on this because I didn't, and I don't even know what does iterator class. I just know like it has next iteration or
Yeah.
iterator class Python, like what does it do and things like that. Like how do you even implement it, I don't know. Yeah, it only has next method, right?
Yeah, next
Hmm.
method and yeah, mostly just next method.
Hey, do you know if like they asked you like if could you have used a iterator, like an actual iterator within iterator, or no, or they wanted you to like not use it and use like basic data structures in it?
Well, that guy he asked me straight like, do you know what's iterator? And then I said iterator. I talking about for loop or while loop. He said no, it's iterator. And then I said I don't really know what it is. And then but he still keep going to ask me to
Mhm.
code it up. So it was really brutal for me. I didn't even know the next method at that time.
Yeah.
So I struggle a lot, and and not surprised I bombed it. So
Yeah, because you have to
yeah.
know it to be able to like implement, and I think you were at a disadvantage because you had to like understand on the spot and implement on the spot, you know?
Yeah, that question was not very not the most popular one, so I wouldn't like spend a ton of
Mm.
time, like given that you only have 1 day, 1 or 2
Yeah, yeah,
days,
yeah, yeah.
and yeah, but I would like spend like some amount of time to object
Oriented.
coding.
Yeah,
Yeah,
that's
yeah,
actually
yeah.
really
So
true. I think I should do that in case if they ask. But thank you for the tips, and I really appreciate it. Like, you know, and I'm glad I met someone like me who is switching their background too. How long have you been studying?
yeah, let me show. Let's get connected on LinkedIn.
Oh
One
yeah,
sec,
yeah, that's a good
and then
idea.
you can see my background. Actually, I've been doing this for the past year.
Yeah.
Uh, it's not easy. It's not easy.
Oh, you are doing it. Oh, that's actually for 1 year. You are doing like a really good job.
Oh no
I
no.
also.
Yeah. I actually I've been doing like coding interviews for like 3 or 4 months, but I've been
Yeah.
like transitioning in the past year. Yeah.
Yeah, you're doing really well. If you ever wanna, I mean, it's not all like gonna cover it, but there is like this website called Geeks for Geeks, right? It has
Yeah.
a
Yeah. Yeah.
Python course that I think I use that to get started, and then there is a another thing that I'm gonna give you. Hold on. How do I find it? Pen. I know this doesn't sound like why do I have to do AI class, but make sure you do like week. Um, I feel like it's like, yeah, homework one. Yeah. So week one, homework one, it covers like a ton of Python, or yeah. So this is the class I'm taking right now. And I thought I knew Python until I took this class, and like they were like generators. Then, you know, on top of iterators, they have generators, so it can yield things without loading it all into the memory. Like, so you don't have to have everything in the memory. So I didn't even know these things existed, you know. So I would
Yeah.
say this guy covers
That's a
it. Yeah.
yeah. That's a exact the same question, and I was get asked like, what's the advantage of using a iterator? That's exactly what you said, right? You basically load one row at a time, right? So you
Yeah.
save a ton of memory. Yeah, I was
Yeah.
asked that question by Google.
Mhm.
I didn't know the answer until recently after I know what's generator and iterator.
Yeah,
So
I didn't know either. There is also something like serializable or something interface in Java. So I think there is something like that in Python as well. So I think that's something good to know. I really don't know still how to do it, but I know these Geeks for Geeks that I told you, it also has another class, data structure and algorithm, but this one is in Java and C++. And I would say, like, if you feel okay with Java, I would recommend having it, because every single basic question, it all gets covered by these courses, you know. And the guy actually like does a video on it, and he explains it like so well, and it's only like $30, not like so much other people charge, you know. So I found it helpful. But I feel like for 3 months, like, you are so good at this already, you know. So I would say keep going at it. I think see what happens within 1 year if you keep at it, like, because you will be so much better. Yeah.
yeah,
Oh, and
hopefully.
you will be. And like another thing that I found, like, this guy works at Amazon. He's like a senior software engineer, and he told me that sometimes like people are like really sucky coders and really sucky developers, but because they are so good at interviews, they get all these positions and title and money. So he said that just make sure you never like not do well in your interviews. Like, that's like the most important thing, you know. So yeah. Wait, where is your link pin that you said you sent?
It's right
Or
here. Then yeah,
where?
you
Oh, okay, okay, I found it.
you are you are doing really. How long have you been doing data structure algorithm? You are doing really
For
well.
for a while. I actually give I do it and then I give up, you know. So oh wow, you have a lot of, like, I don't know what FSA, FCIA, but it looks like a lot of certification for actuary, right?
Yeah,
So
yeah. I'm
I
actuary actually.
yeah, it requires a lot. Maybe you can be a quant, you know. I think if you're
It,
good at it, like
it it is hard to do CPA. I know it takes a very long time to do CPA. I have friends. I mean I have colleagues. I mean I'm in finance, right? I have a lot of
yeah.
accounting friends. They in CPA. I mean if they
Mhm.
reach CPA like a goal destination for them, but and
Yeah,
yeah. So I know
I
it's not
moved past
easy.
it. I did it when it was easier. Like I think now they changed it and like made a lot of changes or something. But like yeah, I think I took my CPA right after school and I only had like two exams left when I started with Ernst and Young. And then I finished it and I'm like, I don't want to look back. I just want to have certification done and move on. But now I'm like, I'm so done with tax and accounting. I want to be a programmer, you know. Hey, I will tell you
Yeah, yeah.
something. You see how your LinkedIn has this thing at the end? Oh, is this by I think this is default, right? Like this URL.
Yeah, yeah,
So
it's
you can
default.
do it like this. So let me show you mine. You can just set it like this. Hold on. Let me see if I can find it. So you know, like you can create it like this. So you can only have like whatever you want this to be, this part to be yours.
How do you do that?
There is a setting for it. I think you just have to go to settings and
Okay.
I think there is something you can do, because if you're doing job hunting, this is very helpful. um
Oh, okay. I will do some googling around that. Yeah, so you can
yeah,
have a customized URL.
yeah, this part you can, the first
Wow.
part you cannot, obviously, you know. So
Yeah.
you can do it
Let
like
me
this. Yeah.
let me send you a request. Oh, that's good to know. On
Oh, I
customize.
just added you. You didn't get my
I haven't
uh,
seen your request.
let me try again. Okay, I think I
Yeah,
just added again. That's really weird that it didn't. Maybe it takes time because you are in
wow, you
Canada.
are 4.0. That's impressive.
Nah, no, it's not. Like it is what it is. I don't know how I got it. I hope I can keep
This
up
is
with it or something.
this is really good program. Yeah, I was thinking about this program. The master. Does you're in camp or you're online, right?
Yeah, I am online, but I actually think there is another program from Georgia Tech.
Yeah, yeah.
That one is good too, but
OMS, yes.
yeah, but they don't have TA support. Like I think our program has TA support, but my program has like very few TAs sometimes. It's kind of annoying, like, you know. So I mean, I
Yeah,
don't think you need to. You don't need to do it
yours
again.
is expensive. Your program is expensive.
It's
I was
really.
comparing that.
How much was your
Yeah.
program?
Right now UT Austin like 10,000 for the entire program, and
Oh,
it's not.
really?
Yeah,
Oh,
yeah.
yeah,
I
mine
was
is
thinking about your
25.
program.
25 something. You can just have your employer pay. You can just have your, but you already gonna get a master's, right? So they may not pay again, you
Yeah.
know?
Yeah. So how far in you are in the you started in 2019, right? How many courses
Yeah,
left for you?
I could finish like next semester, but I'm extending it because I want to see if I can get an internship again, you know? Because I don't like interview process as much. So I think like if I can get an internship in a company that can pay slightly higher than Qualtrics, then I can get into that company, you know, and then just stay there for a bit until I prepare and get better at interview practicing again and try again with like Fang or something, you know. So I
You
mean, I only have two more classes left after this class. So I could
yeah.
finish it off sooner, but I'm just taking time.
My feedback to you to your overall interview you have an amazing communication skill. I've seen a lot of
Really?
guys. I've been in on prom like a 30 or 40 times. I've seen a lot of people on prom.
Oh, really?
Your
Wow. Thank you.
yeah I well this is really helpful for me to
Yeah.
improve my communication skill. And but you have an
Hmm.
impressive communication. You basically discover discuss all the edge cases up front. You have I
Hmm.
can show you, you also demonstrate a well thought process, right?
Hmm.
What case is being covered and what's not. And also you discuss the optimized potential optimized solution. So
Mm-hmm.
I think
Thank you.
yeah, you've done really well on the communication skill, and sometimes like today when you get stuck, don't I
Mm-hmm.
mean try to use the interviewer as a
Resource.
friend to
Yeah.
navigate you to be where you want to
Mm-hmm.
go. And I
Yeah.
think you're getting that really well. So I think you
Mhm.
just have to like yeah.
Mhm.
So yeah, that's a big plus for your in. I
Really?
if I was
Thank you.
you, if I was
Mhm.
yeah, if I was you, I wouldn't be so stressed out about the interview process. You've been doing really well because
Thank you. I just have to be good technically because I don't I think this question was simpler, but if it's like really hard question, like I don't know DP so well, like like I really struggle a lot with DP and some weird graph questions, like So I think those are the things I haven't mastered. So I think like how I got stuck with this iterative approach here. Like I'm like, oh, I don't know. So first thing that happens to me is like, oh, I don't know this now. I'm not gonna be able to finish it. Like that's like the first thought that comes, and then I'm just like, kind of like, I don't know what to do, and I don't know. I do that kind of stuff. Like in the interview, I get like frozen, so that's why I started doing Promp. Like, isn't it called Promp? So then I'm like, okay, I can get better at like speaking, and if I get stuck, I can ask. I can see you as my interviewer, and I can be like, okay, let me see if they're gonna give any help, and so yeah, you helped me like get unstuck, so that was really good. So yeah.
yeah. But you've been using lead code, right? So try to like
Yeah.
go to that specific area on lead code, and then you
Yeah.
can grind certain area. Like you can do graph and right. You have been using lead code.
Yeah.
I'm guessing, right?
Yeah, I have lead code premium too, so I can even see solutions. So yeah, but only for like two,
Yeah.
3 months, and I'll be done. I don't want to do interviews anymore for some time. But actually, it's not a bad idea to keep doing prompt, right? Like I can just keep doing like 2 or 3 times a week, just without even preparing. What's the worst gonna happen? I can just say, okay, I don't know. I mean, can we do your problem instead? Like, right? Like it is what it is. So I think I should continue this. Like I like it. So. Yeah.
Mm-hmm.
Well, stay in touch. I'm gonna go drink some water because I have been like here for a bit. So, but it was really nice to meet you and good luck. And I think you're gonna do so well. Just keep at it. And sometimes weird questions come up. Interview is like half luck because the type of question comes, the type of interviewer comes, it all plays a role. So I would not take
Yeah.
that it's all on you. So yeah. But yeah.
Exactly.
Yeah.
Best once again, best of luck to Snapchat. I hope you get it. And
Thank
if
you.
you yeah,
Same
if
here.
you want to come back to prom, hopefully you're not gonna come back to for prom for a while. And yeah, if you but for any reason you get connect you want if you want to get connected, yeah, send me a message on LinkedIn and then we can sit down and chat again.
Yeah, yeah, yeah. Let me see how I can like also make sure that I can I'm gonna like save the oh yeah, 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 your link to the profile is here. So I'm gonna save it like manually somewhere. So and you can also like we can also do Prompt again even without using that credit thing. Like because if you say like do Prompt with a friend, we can do it
Yeah.
and I don't know how that works, but I would love to connect and see what you are up to, especially because you're a career thinker. I'm so excited. So that's really awesome. Yeah. Okay.
All right,
All right.
I'm gonna let you go.
Thank
Best of
you.
luck.
Bye. Thank you. You too. Best of luck. Bye bye.